Good day, ma'am. My name is Lias Licher from BS Marine Engineering Second Year Alpha, and today I am going to discuss my output in R-717 in Mollier. So the given will be the condensing temperature is 30 degrees Celsius. Evaporating temperature is 14 degrees Celsius, negative 14 degrees Celsius. Discharge temperature is equals to 110 degrees Celsius. The superheat is equals to 10 degrees Celsius, and the subcold is 6 degrees Celsius. So in number 1, the question is, what will be the temperature of refrigerant in the suction line and liquid line? So the T-suck is equals to TE plus T-suck is equals to negative 14 degrees Celsius plus 10 degrees Celsius, which is the equals of negative 4 degrees Celsius, which is the H1. So in T liquid equals to TC plus minus T sub equals to 30 degrees Celsius minus 6 degrees Celsius, which is 24 degrees Celsius in H3. So the T suck, which is the H1, the negative 4, which is here, the negative 4. So in 24 degrees Celsius, which is the H3, which is here, the H3, 24. That's why I put a dot here. So, I put a line here, make a line. So, it would be the negative 4, it's here, and the 24 degrees Celsius is here. So, question number 2. Determine from the diagram the high and low side operating pressure. So, the high side is P2 equals to 12 bar. So the P2 is here. So I put the line here because the 12, which is the bar, so here's 11 and 12. And then the low side, the P1, which is 2.60 bar, it's here. 2.60, 2.10, 2.20, 2.30, 2.40, 2.50, and 2.60, which is the line here. So in number 3, the heat rejected by the condenser, Kj equals to kilogram. So QR equals to H2 minus H3. So equals to 1,700 kilojoules per kilogram minus 300 kilojoules per kilogram. So the H2 would be the 1,700 kilojoules. It will be here. That's why here it's a H2, 1,700 kilojoules per kilogram. So in H3, which is here, that would be 300 kilojoules per kilogram. So that's why I put a line here. So we must minus it, 1,700 kilojoules per kilogram minus 300 kilojoules per kilogram equals to 1,400 kilojoules per kilogram. So number 4, the discharge temperature is the 110 degrees Celsius. That's why I put it here, 110 degrees Celsius. So in number 5, the question is the total heat absorbed by the evaporator, kilojoules per kilogram, which is the H1 minus H4, which is 1,460 kilojoules per kilogram minus 300 kilojoules per kilogram, which is the H1, it's here, which is the 1,460 kilojoules per kilogram minus the H2 is 1,700 kilojoules per kilogram. So the answer would be 1,160 kilojoules per kilogram. So the work of compressor in this part, which is the H2 minus H1. So clockwise by low na sad, 1,700 kilojoules per kilogram, which is the H2, minus 1,460 kilojoules per kilogram, which is the H1. It will be, the answer is 240 kilojoules per kilogram. So in number 7, the expansion loss, which is here part. So the expansion loss is equals to H4 minus H4. So it would be 300 kilojoules per kilogram minus 130 kilojoules per kilogram, which is here the H3 and H4 is the same. So I must put the line here. Ana, pareha na sila, 300 kilojoules kilogram, or also the 130 kilojoules per kilogram, which is also a H4, the H3. So atoy kuan minus mo nang it will be the 170 kilojoule per kilogram. So lastly, what is the quality of refrigerant entering the evaporator, which is the liquid percent and the vapor percent. So when we're going to find the percent of vapor, so it is at 0.12 or 12%. So we find the liquid vapor percent of vapor is here. That's why I put a line here, because this is the vapor 0.10. Then ako lang gibana-bana na nahimo siya 0.12 here. So in liquid, we're going to find the liquid is 100% minus 12% equals to 88%. So thank you and God bless.